So it is exactly like last problem, okay, how we saw. For example, using SJF, we need to find out average turnaround time, average waiting time, schedule length and throughput, okay. Now let's first draw the Gantt chart as usual. Our Gantt chart will always start with time unit 0, okay. We'll start with time. And one more important point, even for this problem, we need to assume that no process needs IO time, okay. No process, IO time of all the processes are 0, okay. That is our assumption, okay. That is very important point. Fine. Now, which at time unit 0, again no process has arrived to the queue, right? And no process has arrived to the ready queue, which means no process has come into the main memory, right? So from 0 to 1, our CPU will be idle, which means our CPU will not execute any process or execute any instruction, it will be idle. Fine. Now at time unit 1, only process P1 has arrived, right? Process P1 has arrived to the RAM, and so we might have to start process P1 and we need to go till time unit 8. Why? Because we are using non-preemptive scheduling algorithm. It doesn't matter during this time any other higher priority process has arrived to the RAM or not. We will always execute process P1 because it is a non-preemptive scheduling algorithm. Once we have scheduled a process, we will never preempt that process until completion in non-preemptive scheduling algorithm. Okay, we have seen it already. Fine. Now at time unit 8, every process has arrived to the RAM, right? Or every process arrived to the RAM. Now what we can do? Among all these, we have already completed P1, right? Now among these 4 processes, the process with the least burst time will be executed next, right? Now the process with the least burst time is nothing but process P3, okay? P3 runs for only one time unit until 9, fine. Similarly, next comes process P4. P4 will execute for 2 time units, fine. P4 is also done. Then we might have to execute process P2, right? Because 5 is less than 8. So process P2 will execute for 5 time units, and it will it will go till 16. Fine. Then we don't have any other option. We might have to execute process P5, and P5 will execute till 24 because it needs 8 time units from the CPU to complete execution. Fine. Now let's compute completion time of every process, right? Okay. Let's compute the completion time of every process. Fine. We already know that completion time from the Gantt chart itself, right? Completion time of process P1 is 8. Completion time of process P2 is 16. Completion time of process P3 is 9. Completion time of process P4 is 11. And completion time of process P5 is 24. Fine. Now let's compute turnaround time. Okay. Since our IO time is 0, turnaround time is nothing but completion time minus arrival time, right? So 8 minus 1 is 7, 16 minus 2 is 14, 9 minus 3 is 6, 11 minus 4 is 7, 24 minus 5 is 19, okay? So this is the turnaround time. Now if you add these 5 things and if you divide it by 5, then we will be getting the average turnaround time, right? You can compute it by yourself. It's quite simple, right? Fine. Now after turnaround time, we have something called as waiting time, okay? Waiting time. Now since our IO time is 0 for every process, waiting time is nothing but turnaround time minus burst time, okay? Turnaround time minus burst time, which is 0. Turnaround time minus burst time, which is 9. Turnaround time minus burst time, which is 5. Turnaround time minus burst time, which is again 5. Turnaround time minus burst time is nothing but 11. Okay. So again, if you add all these 5 things and if you divide it by 5, you will get the average waiting time. Fine. Fine. Now we have computed the average turnaround time, average waiting time. Now we need to compute something called as schedule length. What's the schedule length? We have started scheduling, which means our scheduling algorithm has started scheduling process at time unit 1, and it was scheduling till time unit 24, right? So from 1 to 24, how many time units we have? 24 minus 1 is 23, right? So schedule length is nothing but 23. Fine. Now they also has something called as throughput. We know what is throughput, right? Throughput is nothing but the number of processes executed per unit time. Okay. So throughput is nothing but number of processes, and number of processes are nothing but 5. Okay, we have only 5 processes. Fine. Divided by schedule length, and schedule length is to just 23, right? So throughput is nothing but 5 by 23. Okay, I think it's quite simple, right? Now you should be more comfortable with this. Okay, fine.